Okay, let's do this. So we are Unit 9, Day 3. This is Intro to Bearings. Okay, so let's start off with what a bearing is. So a bearing is an angle that is always measured clockwise from the north/south line. And this will make more sense once I do a couple of problems. A bearing tells us how to navigate from one point to the next. Okay, so let's say I have a bearing. Here's an example of point B from point A. So I have a bearing of point B from point A. Wherever it says of to, that's where you're going to. Wherever it says from, that's telling you where you're starting. So even though it's coming sort of second in that sentence, bearing of point B from point A, always look for the from. Wherever it says from, that's your starting point. So it says from A, we're going to start at A, and then where are we going to end? B. So here's my A, here's my B. Okay, so now the bearing, what we're going to do is we're going to go from point A and we're going to use that north-south line. So I'm essentially putting a vertical line through A. Is it not letting me change my colors? Oh no, it's frozen. Now what do I do? There we go. All right, so I'm going to use a vertical line, and I'm really only using the north part of this vertical line because B is above A. So I don't really care about the south part of this vertical line. So remember, bearing's always coming from the north-south line of our start point. So I'm going to draw my north line, go north of it, and then from there, I go and connect from my start point to my end point. This theta, that angle, that is our bearing. So this is the bearing of point of B from A, that angle. Okay, now keep in mind the bearing from point A to point B is different than the bearing from point B to point A. They're not going to be the same. All right, let's do some examples. I want us to sketch a bearing of 42 degrees. You can sharpen, it's fine. So if I'm going to sketch a bearing of 42 degrees and it doesn't tell us north, south, east, west, it doesn't give us any sort of direction, all we're going to do is we're going to make up a point. We'll always go north. And then from there, going clockwise, we always work clockwise. We draw what we think would be like a 42-degree angle. So we always move clockwise. From north-south line. So if I had to give this bearing a direction, so here's my bearing of 42 degrees. If I had to give it a direction, remember, never eat soggy waffles. You guys remember that? All right, so if I had to give this bearing a direction, here's point A, do you agree? We're going up and then right, so it's northeast. The way we would write that is north 42 degrees east and 42 degrees E. Okay, next one. So now I'm going to say the bearing is 164 degrees. So here's my point A. I'm going to go north. And then we're rotating clockwise. Henry, no, put it away. I don't care. All right, so now if I'm going 164 degrees, well, we know if I were to draw a straight line, wouldn't that be 180 degrees? So 164 degrees would maybe be like that, less than 180, but more than a right angle. So here is my clockwise 164 degrees. Now the bearing direction is always the acute angle. So when I talk about the bearing direction from point A, right now it's not going to be the 164, but do you see how there's another acute angle here? It's actually going to be this angle theta right in here. So if I ask, what is the direction of this bearing? Remember, we were starting at point A. Never eat soggy waffles. Well, if I was starting at point A, do you all agree we're going south? But then which way? Southwest, southeast, just south? Where are we going? South, east. So this would be, well, can we figure out how many degrees this angle is? Yeah, how? Good. Because that straight angle, that straight line is 180 degrees, we're going to do 180 minus 164. And we end up with 16 degrees. So this is going to be south, 16 degrees east.
How do you know which one to put first?
It's always north or south first, and then east or west. Riley had a good question. She said, sorry, I called you Riley. I'm so sorry. Morgan had a good question. She asked, how do you know which one to put first? It's always north, south first, and then east, west. All right, last one like this. Bearing of 304 degrees. All right, so here's my point A. Here's my north-south line. I'm starting at point A, and I have to go clockwise, right? Well, if I'm going clockwise 304 degrees, do we all agree a full circle is 360 degrees? So I have to go less than a full circle. So let's say we're like here. Now my bearing direction is not going to be that 304 degrees. How will I find the angle in here? Any ideas? How will I find this theta?
360 minus 304.
You got it. 360 minus 304. And we get 350. Oops, sorry, just 56. So this is 56 degrees. Now, if I had to put a direction on this 56 degree bearing, what would we say it is? You got it, northwest. So it's going to be north 56 degrees west. All right. We are also going to bring in geometry into this. Do you guys remember parallel lines? And if you had parallel lines, there were a whole bunch of different angles that we can say are congruent. Let's just recap. Okay, so if you remember from geometry, if lines are parallel, then alternate interior angles are congruent. Who remembers what letter the alternate interior angles made with the parallel lines? Does anybody remember? So these are my parallel lines. This is my transversal. The alternate interior angles are the angles in the armpits of the Z. Do we see how that rotated could be a Z? Right, so it's the angles, let's say 1 and 2. If the arms of the Z are parallel, then the angles in the armpits are congruent. So if the arms of the Z are parallel, Henry, you have to put that bone away. If the arms of the Z are parallel, then not in your pocket. There you go, much better. If the arms of the Z are parallel, the angles in the armpits are congruent. Right, so that was the first one. We also have the angles in the F, which are corresponding angles congruent. So here, if these are the two parallel lines, the angles in the armpits of this F will be congruent. All right, there's one more we need to know. Interior angles, same side of transversal are sub. And what that looks like, if we have our two parallel lines and you make a very boxy looking C, do you see that very boxy looking C that I've created? The angles in the armpits of that C, they are not congruent. 5 and 6 are sub. What do I mean when I say sub? They add up to 180. Yep. All right, are we ready for some word problems? Maybe. All right. A steamship 23.3 kilometers due south of Lighthouse A. From Lighthouse A, the bearing of Lighthouse B is 90 degrees. The distance between the two lighthouses is 26.5 kilometers. Find the bearing of Lighthouse B from the steamship to the nearest minute. All right, the hardest part of these word problems is creating the diagram. Once you create the diagram, it shouldn't be so bad. So we're going to go step by step. A steamship is 23.3 kilometers due south of Lighthouse A. So what I'm going to do is I'm going to have my Lighthouse A. Here's A. And it's not saying southeast, it's not saying southwest, it's saying strictly south. So I'm going to use my south line. And here is my steamship. There's my ship. And from Lighthouse A to the steamship is 23.3. Okay, so now they're saying from Lighthouse A, the bearing of Lighthouse B is 90 degrees. So what I have to do is I have to start at A, I have to go to B. But remember, our bearings are always clockwise. So what I have to do is my north-south line, I have to sort of increase that a little bit. And now from that north-south line, I'm going to move 90 degrees, right? There's my 90-degree angle to Lighthouse B. The distance between the two lighthouses is 26.5. So this is 26.5. Find the bearing of Lighthouse B from the steamship to the nearest minute. Right. Find the bearing of Lighthouse B from the steamship. So are we doing the bearing from B to the steamship or from the steamship to B? Because it says from the steamship. So we're starting from the steamship, we're going to B. So remember, the bearing is always made with a north-south line and then whatever direction we're leaving. So I already have my north-south line from the steamship, right? So all I have to do is make my other ray towards B. And this is what we're trying to find. Do we agree if this is a right angle, then this angle right here is also a right angle? All right, so now we have our right triangle. We have everything we need. Here's my right angle. Here's theta, 26.5 and 23.3. So I have the adjacent and the opposite. So we're going back to SOHCAHTOA. We're going to use tangent. Tangent of theta is the opposite, which is 26.5, over the adjacent, which is 23.3. Theta will equal the inverse of tangent of 26.5 over 23.3. Now, I asked to the nearest minute, right? So we can put that right into our calculator right away. So let's take out our calculators. I'll remind you how to do that. So we are going to do second tangent. We're going to put in whatever it was, 26.5 divided by 23.3. We're going to close that parenthesis, but do not press enter. Now, in order to have our answers in degrees and minutes, what we're going to do is we're going to press second app, choice number 4, and now you press enter. So I said round to the nearest minute. Well, my degrees is 48. Right now my minutes is 40, but then it's 35 or 36 seconds. Do I round up or do I leave it the same? Round up, because 30 or bigger, right? We'd round up because that's our halfway point. So this is going to be 48 degrees and 41 minutes. You cannot figure out a lot of these problems without a proper sketch. All right, let's do the next one. A ship travels 70 kilometers on a bearing of 27 degrees and then travels on a bearing of 117 degrees for 180 kilometers. Find the direct distance from the endpoint to the start point. Round to the nearest thousandth. How many decimal places is thousandth?
3.
3. Good. All right, let's get our diagram going. A ship travels 70 kilometers on a bearing of 27 degrees. So I have my start point. I'm just going to say right here, start. Now it's not saying north, south, east, northeast, southeast, southwest. It's not saying any of that. So what do? We just make our north line and go clockwise. So they said 27 degrees. We'll say that's about our 27 degrees. Okay, so now we're stopping, right? So they go 27 degrees for how many kilometers? 70 kilometers. Then what happens? Then travels on a bearing of 117 degrees for 180 kilometers. So again, it's not giving us a direction. It's not saying northeast, southwest. It's not saying anything. So what do? We just make it north. And then we go 117 degrees. Do we agree 117 degrees will be less than like a strict 180? So if that's my 180 line, I'm going less than that. So this is 117 degrees right there. And how many kilometers was that? 180. and this is where we end. Find the direct distance from the endpoint to the start point. So do we agree we're trying to find this length right here? Anybody confused with any part of my diagram right now? I'm just fixing my diagram. Oops, I put degrees here. That's not degrees. That's 180 km. This is 70 km. Okay. We good? Okay, so we want to find this distance. Well, we have a triangle, but do I know any angles in this triangle as of right now? No. But anytime you have more than one north-south line, those lines are going to be parallel. What do I mean? Do you see this north-south line and this north-south line? Those two north-south lines are parallel. Anytime you have more than one north-south line in a diagram, they will always be parallel. Because they are parallel, there's so many different ways to do this, but I'm going to go with the Z. Do you guys see that Z I have right here? Because of the Z, that means this angle right here is 27. So I'll highlight the Z real quick for you, and then I'll erase it because there it is. There's that Z. So this is 27 degrees. And now, do you guys see this straight angle right here? Well, what is the relationship between that 117 and this angle right in here in the triangle? They have to be supplements. They have to add up to the 180. So that other angle is going to be 63 degrees. And what's 27 plus 63? 90. Look at that. We have our right angle. You will always somehow find a right angle in the triangle using the parallel lines or anything else that I've given you. Yes.
So the 117 and the 63 were the, what are they called?
No, that wasn't an interior same side sub. This was just a straight angle. A straight angle adds up to 180 always.
Oh, I see.
So here's our right triangle. We have 70 km here. We have 180 km here. And we're solving for x. So this isn't trig at all. What am I going to use here? Pythagorean theorem. Yep, we're going to use our Pythagorean theorem. So we have 70 squared plus 180 squared equals x squared. So do you guys all agree x will equal the square root of 70 squared plus 180 squared? So we could type that right into our calculator just like that. So let's go to our calculator. And I'm going to press second x squared, which gives me the square root button. I'm going to open up my parentheses, and I'm going to type 70 squared plus 180 squared. And close my parentheses and press enter. So I said round, did I say round to what? Thousandth. Okay, so I said round to the nearest thousandth. So we're 193.132. km. All right, two more problems. Anybody still copying this one? All right, next one. Radar stations A and B are on the east-west line, 3.7 kilometers apart. Station A detects a plane at sea on a bearing of 61 degrees. Station B detects the same plane on a bearing of 331 degrees. Find the distance from A to C to the nearest thousandth. So do you guys want to try to set up this diagram yourself, or do you want me to do it with you? With you? Okay. So it says radar stations A and B are on the east-west line. So what's the east-west line? A horizontal line, exactly. So here's my A. I'm going to actually move down a little bit just so I have more room. Here's my B. This is 3.7 kilometers. Station A detects a plane at sea on a bearing of 61 degrees. Okay, so how are we going to make this bearing from A? We've done a few problems right now. You should maybe have a guess, even if you're not confident in your guess. Morgan?
You draw a north line, and then 60 degrees is between 9 and 10.
Yep, we draw our north line, and then 60 degrees will be like, doesn't matter, we'll say here. And then they say, where's that to? Point or plane C, right? Yes.
61.
Oh, 61? Okay. Okay, next one. Then it says station B, so now we're starting at station B, detects the same plane, so same plane C, on a bearing of 331 degrees. So what am I going to do there? Well, I'm going to draw my north line. And then now we're doing 331 right there. Now, do I really care about the 331? No, I don't want the 331. Which one do I want? This one in here. How do I find that angle in here? Subtract from 360. You got it. So then we will get 29 degrees over here. In our diagram right now, are there any parallel lines? There are. Which ones? The two north lines, right? This line and this line, they're parallel. Okay. Now, I'm not assuming this. I know this. Because they told us the A and B are on an east-west line. An east-west line, is it lifted at all, or is it perfectly horizontal? The east-west line is perfectly horizontal. And isn't a north line perfectly straight? So what happens when a perfectly straight vertical line meets with a perfect horizontal line? They get their right angles. Exactly. So what does that mean? That means there's a right angle here and also a right angle here. Why does that help me? Any ideas? Because of what? You could fill in the inner angles. So if this is 61, wouldn't this have to be 29? And if this is 29, wouldn't this have to be 61? So what does that mean for angle C? It's a right angle. So they want us to find the distance from A to C, so this segment right here, which I'll call X, to the nearest thousandth. So I'm going to use my right triangle. Does it matter which angle I use, the 29 or the 61? No, I'll use the 61. So I have my opposite and the hypotenuse. How do I know 3.7 is the hypotenuse? Good, because it's across from the right angle. So we're going to say sine of 61 is equal to x over 3.7. So x will equal 3.7 times the sine of 61. And you all could enter that into your calculator. If you do that, we get x is equal to 3.236. What is it? km? Km. All right, last problem. All right, two cars leave an intersection at the same time. One, it should say one, not on. One heads due south at 55 miles per hour. The other travels due west. After 2 hours, the bearing of the car headed west from the car headed south is 324 degrees. How far are they at that time? All right, we need our diagram. Let's get started. All right, so here's my starting point. They're starting at the same spot. Two cars leave an intersection at the same time. One heads south at 55 miles per hour. Does it say southeast, southwest, or is it strictly just south? Just south. So we're going straight south. And this is my south car. The other travels due west. All right, so we're starting, and now it's not saying northwest or southwest. It's saying just west. Oh, I went east, sorry. Uh-oh, what happened? There we go. West. So this is the west car. All right, then it says after 2 hours, the bearing of the car headed west from the car headed south is 324 degrees. All right, so they're saying after 2 hours, the bearing of the car headed west from the car headed south. So where is our bearing coming from? The west car or the south car? South, because it says from the south car. So we're starting at our south car. And now they're saying it's 324 degrees. Can I find that angle right in here? Yeah. It's 360 minus 324, which is going to be 36. Okay, now let's go back. They said the car that's heading south, let's go back here, is traveling at 55 miles per hour. How many hours were the cars traveling for? 2 hours. So if you're traveling 55 miles per hour for 2 hours, won't that be 110 miles? So what does that mean? From our start to our south point, how many miles is that? 110. So I wrote it out just so you guys know where we got that number from. 55 miles per hour for 2 hours. That's where we got that 110 from. But then it's saying the west car, did it tell us how fast the west car was traveling, or it didn't say? That's it. Okay. So now we want to find how far are they at that time. So we want to find the distance from the south car to the west car. So we're trying to find x. Do I have enough information right now to solve for x? Absolutely. Did we need to know this angle in order to do that? 100%. So now we have the 110 is the adjacent. Do we agree this is our right angle right here at the start? And this is our hypotenuse. So we're going to say cosine of 36 is 110 over x. So then we have x times the cosine of 36 equals 110. So x will equal 110 divided by the cosine of 36. Let's do 3 decimal places. And you should get 135.967 miles. Okay, so we are done for